In this lesson, we will be looking at a couple examples of exponential functions. In general, an exponential function has the form y equals a times b raised to the x power. The a in this formula represents the initial value, or the y-intercept, and the b represents the factor. Now, a couple things to think about with this factor is that if it is greater than 1, then we have an exponential growth function, so it's an increasing function. But if the factor is between 0 and 1, then we have an exponential decay, so we have a decreasing function. For our first example, let's consider a new baldness cure that has achieved such good results that the sales of the cure are growing exponentially and can be modeled by the function s of t equals 15,000 times 1.085 raised to the t power, where s is the sales in dollars and t is the time in weeks. If we look at the formula, the a is this 15,000, so that's the initial value, and the b, or the factor, is this 1.085, which is greater than 1, so that tells me right away that this is an exponential growth function. Now let's look at the graph of this function. So let's graph the function over the first 30 weeks. If we go to the y equals screen, I've already typed in our formula, and we use x instead of t. If we go to the window, we want to do it for the first 30 weeks, so x min is 0 and x max is 30. And then we can do zoom, and easiest is just to do zoom fit. And so this is what an exponential growth function will typically look like. It's an increasing function, and it is concave up. In this case, it's increasing at an increasing rate. Let's compute the value of s of 20 and interpret its meaning. To do this, we can just go to the trace button on our calculator, and we want to type in the number 20, and we can press enter. This tells us that after 20 weeks, the sales for this new baldness cure will be $76,680.69. What is the weekly growth factor? If we remember our formula, the factor is whatever number is raised to our variable power. So in this case, the factor is 1.085. Now it's the weekly factor because t is already in weeks. So our weekly growth factor is 1.085. What is the weekly growth rate? Well, we know that the factor is 1.085. And we have a relationship between a growth rate and a growth factor where the factor is equal to 1 plus the rate. So in this case, if our factor is 1.085, that's equal to 1 plus whatever the rate is. So to find the rate, you just subtract 1 from both sides, and so we get that the rate is 0.085. And we can convert this to a percentage, which means that our weekly growth rate is 8.5%. Now let's look at another example. In the second example, we have a certain non-steroidal anti-inflammatory drug where the amount in the bloodstream is declining every hour, and it can be modeled by our function q of t equals 100 times 0.8125 to the t power, where q is the amount of the drug in the bloodstream in milligrams and t is the time in hours. Let's again graph our function. This time, since t is in hours, let's graph it for the first 8 hours. And again, I've already typed the formula into my calculator. And if I go to the window, I have 0 as x min and 8 equal to x max. And again, we can do zoom fit. And so we have a typical exponential decay graph. And it's decay, if you look at the formula, our factor is less than 1. It's between 0 and 1, which tells us it's decay. So the graph is decreasing at a decreasing rate, which means it's concave up. When will the amount of the drug be 40 milligrams? Let's go back to our y equals screen and put in 40 for y2. We have our exponential decay graph. We want to find where it intersects the line y equals 40, which we can do by going into the calc menu and selecting number 5 for the intersection. And we can just select the first curve, the second curve, and the guess by pressing enter each time. So we get an intersection that's 4.41 and y is equal to 40. What is the hourly decay factor? Well, again, if we remember, the factor is the number in our formula that's raised to the exponent. And it's an hourly factor because t is in hours. So again, the hourly decay factor is 0.8125. So what is the hourly decay rate? Well, again, we know that the factor is 0.8125. And since this is decay, we have a similar relationship where the factor is equal to 1 minus the rate. So notice the difference this time. It's 1 minus the rate instead of 1 plus. We know the factor is 0.8125, which will then be equal to 1 minus r. And if we solve this for r, we'll get that the r equals 0.1875, which again, if we convert this to a percentage, this would be 18.75%.